First, I'll explain how we generated our plant modules on the facade. We generated the building and we deconstructed it in order to select the south-facing facade. We placed the hexagonal polygon on the building and moved it so that the origin wasn't placed in the corner. We extruded the hexagons, kept them, duplicated them, and then these two modules we use linear array for in order to create columns and rows. One way of improving this script would be to have the number of columns and the number of rows in the hexagonal panels be influenced by the shape of the building surface, so that this would automatically generate the amount of panels in the building. Now, how did we draw our rectangular PV on top of our hexagonal green modules? We took the center from our green modules and moved it to the surface of the green modules. From the surface of the green modules, a column extrudes, which is this, by 30 centimeters. Then we drew our PV panels in this frame, but since they are drawn from the corner, we had to move them so that the PV is supported from the center by the PV column support. We inclined our PV panels gradually. This one moves the bottom of the PV on the facade, and this one moves the top. Instead of having a gradual difference in inclination between the top and the bottom of the facade, it might be more useful for future optimizations to have each individual row be adjustable in inclination. We generated our surrounding context from OSM data from Madrid. OSM data only gave us our plots, so we had to extrude the buildings ourselves. We estimated that the buildings were between 30 and 50 meters tall, and we used jitter to randomize this effect in steps of 2. Then the buildings we had to remove one from in order to place our own buildings in line, which we used the call index for. And we rotated them so that our buildings is perfectly on the street level. Our radiation analysis we did through Ladybug. We generated a weather matrix using weather data that we found online for the city. And we want the sky matrix to be analyzed for all days of the month. We use 28 because of February, all months of the year, and all hours of the day. This sky matrix we used to have a radiation analysis on the geometry that we generated before, the angled PVs. The vector is the north, and the context was provided by ELK. Both these components you can toggle off if you don't want them to be running all the time. The weather has been set to the average of the location instead of a specific day on which there is sun, in which the PV panels would be working. So this is another opportunity for optimization. We used Galapagos to optimize the tilt angle of our PV panels using the sliders here. We used mass addition to count up all the rows. And this needs to be as high as possible, which is why we put this on maximize. We did take into account that the panels on top will shade parts of the panel on the bottom, which will reduce the radiation fallen on the panels on the bottom. Real PV panels, however, are affected more than just the part that is shaded because of PV stringing. Other parts of the panel, which are not shaded, might also be affected by the shade. This, however, is not being taken into account in our script, and it would be an opportunity to improve it.